Okay. Now we are doing transformations of power functions with positive integer index. Now you guys already know what these looks like. So if we've got an odd index, so we've got a 3, a 4, sorry, not a 4, a 3, a 5, a 7, a 9. Okay, but you know that a cubic out looks like, and the others you can sort of figure out. You know that it has a stationary point at 0, 0. If you have an even index, so power of 2 or 4 or 6, you're going to have something that looks like this, right? So grade 2 we know is a parabola anyway, but and we know that we've got that turning point at H and at K. We know that. So we're going to use all the knowledge that we've learned over the time to graph these. Okay, the first example. Now I did it on calculator because it's easier to show you on a calculator. You can see the graph better. But sketching this one, we know that there is the, I'll call it the point of inflection because that's what it is, at x equals to 1 and y equals to -4. We know it's a cubic, so that's pretty easy. And we know that it's upside down because of the negative, and there's a dilation factor of 2. So we know, just sketching this, that it's going to be at 1, -4. That's where I'm going to get this point. So it's going to look something like this. Oops, that should be 1, -4. You should always find where it's crossing the x and y axis all the time. Make sure you do that. I didn't do it over here because it was on calculator, but when you sketch them, always show every point. Don't make a curve in here like I did. It should be coming out still further and further, right? Any questions on that one? Okay, let me clear this one. Example 2. It says find the rule for the image of the graph of y equals x to the power of 5 under the following sequence of transformations. Okay, there's a reflection in the y-axis. Now, we know reflection in the y-axis, we put the negative, the reflection, which is the negative on the x. So there it is there. Dilation of factor 2 from the y-axis, and again from the y-axis, we put this dilation on the x, so it becomes minus the 2x. 2 translation of 2 units positive direction of the x, there it is, plus the 2 there, and 3 units in the positive direction of the y, there it is there. So my x dash, my image, equals minus 2x plus 2, and my image for y equals y plus 3. We rearrange them, make x the subject. So we get x dash minus 2 divided by the -2 will equal the x, and the y will equal the y dash minus 3. That's how I got those. And then we're going to substitute them in here to find the image. So we get y minus 3 is going to be x minus 2 divided by -2 all to the power of 5. I took out the dashes. Okay. Now, simplify that. We know that -2 to the power of 5 is -32. Because it's in the denominator, I've taken it out the front. And so it looks prettier. And then I've brought the -3 across and it becomes the +3 there. Okay, this now should be stuff that you've done if you've done all the questions. Any questions there? Okay, I'll have to clear it in a minute. Forgot to clear it. All right, next example. Now this is actual question 6 from 3G. So if I've set 3G question 6, please don't do question 6. Maybe pick another question. Okay, and example 4 is 3G, your last question, question 9. So again, if I've set that one and I haven't set question 8, maybe do question 8. Okay, and it says find a sequence of transformations which takes the graph of y equals x to the 4 to the graph of that. Okay, well, we can do it by inspection. I'm showing you all the steps here. The first thing I'm going to do is, because that is a y equals to 5 minus 3x plus 1 to the power of 4, I'm going to get rid of my 5, so I get y minus 5. And now that's gone, so it's just got the -3 times that, so I'm going to divide by the -3. Equals my x plus 1 to the power of 4. And of course, this is the image, so I'm just going to put it like that. So now I'm going to equate my y equals this, my x equals, just inside the bracket, because I've already got x to the power of 4, so I don't need to worry about the 4. So I just want to know x is equal to that, my x dash plus 1. Okay, I don't know why I've got a 4 there, that's wrong, that should be a 1. And therefore that will be a 1. Is the other one right? Rearrange this one here. I'm going to get -3 times y plus the 5. That's correct. And that, but my answer's right. So I just change those 4s to 1, please. They should be 1s, not 4s. Erase them. And that should be a 1. That should be a 1. Okay. So then I have found that my x dash y dash is actually x minus 1 and -3y plus 5. Don't know why I wrote that there. I don't need that there. So I can see that I have a dilation factor and a reflection in the x-axis. So I've got a reflection in the x-axis and I've got a dilation of factor 3 in the x-axis. That's what I should have written up to here. Dilation of factor 3 and reflection in the x-axis, yes. I also have a translation of 1 unit in the negative direction of the x-axis and 5 units in the positive direction of the y-axis, which I should have written there as well. Okay, any questions there? Again, this is stuff I've already done. They're repeating here. They want you to use transformations to do all this. We've done it before. They're just pulling everything together. Okay, I'm about to clear that. Example 4. Again, as I said, this is question 9, so don't do this one. Maybe do the previous one, question 8. The graph of y equals a x minus h to the power of 4 plus k has a turning point. Turning point at 1, 7 and passes through the point 0, 23. So we've got a turning point, passes through that point from the values of a, h and k. Well, we know if it's the turning point, well, this rule is in the turning point form. So already we know that h equals the 1 and k equals to 7. So I'm going to put them in here. So I get x minus 1 and to the power of 4 plus my 7. We also know it passes through the point 0, 23. That should be a 0. It looks like an O, but it should be a 0. Substituting 0 in there for x and 23 for the y. So I get 23. -1 to the power of 4 is +1 because that's a 0 minus 1. It becomes +1. So I get a plus 7. So a equals 16. So I found all my values. Any questions with example 4? Okay, I'll clear this one.